Okay, the second part of lecture number 18, we talk about polymer concrete. Okay. So for polymer concrete, actually we have three different type of polymers and concrete. Okay. So we have the first one, polymer concrete, which polymer is used as the only binding agent. There's no cement, there's no water, only polymer and the airweight. The second one is called polymer Portland cement concrete or latex modified concrete. Okay, so this is the concrete uh, similar to traditional concrete, but we add polymer as a type of admixtures. Okay, and the polymer also replace part of the mixing water. That's cement, that's mixing water in this latex modified concrete. Last one is called polymer impregnated concrete or PIC. Okay, uh, this is the concrete which is cast as traditional concrete, but later on we dry the concrete and we impregnate polymer into the pores and the cracks of the concrete to improve the performance. Okay, so this is the third and last one. So here is a little bit a history about polymer and concrete. Both polymer concrete and latex modified concrete has been used for more than 70 years, since 1950s. For polymer impregnated concrete, PIC, it is used around 20 years later, 1970s. Okay. The strength of polymer concrete can be very, very high, as we can see up to 20 KSI and even higher, which is around 140 megapascal. It can achieve the strength within hours or even several minutes. This is very different from traditional Portland cement concrete, okay, which will take normally 28 days to achieve more than 90% of the final strength. And because of that, we normally use polymer concrete in emergency repair jobs. So latex modified concrete has very good bonding ability to existing old concrete, okay, and can also provide very high durability. So the harmful solutions cannot easily penetrate to do the damage in the concrete. Okay, and because of that, we mainly use latex modified concrete for in overlays on the floors and also to do the rehabilitation or deteriorated bridge decks. So that is latex modified concrete. Okay. For polymer pregnated concrete, we use the polymer to seal the micro cracks and also the pores inside existing concrete. Okay, if we feel the existing concrete is weaker and less durable, we may want to use polymer to seal these cracks and pores. Okay. Can achieve very low permeability in the concrete. And because the procedure to apply the polymer in the concrete in PIC is kind of tedious. So normally we use that in precast plant. Okay. So polymer concrete, which is the first type of polymer and the concrete, is a mixture of aggregate together with polymer as the only binder, the sole binder. Okay, And because the cost of the polymer is much higher compared to other raw materials, so it is important to achieve the maximum possible dry packing density of the algae, because when we enhance the packing density of the algae by using different sizes and better gradation, we can reduce the amount of liquid, which is in this case the polymer, to fill all the gaps. So we can reduce the amount of expensive polymer. Another important factor for polymer concrete is the algae need to be oven dry. Okay, there should be no moisture on the surface and inside the algae. The reason for that is because the polymer does not like moisture. Remember, this is for polymer concrete only, which means the concrete does not have other binders such as water and cement paste, only polymer and algae. In that case, we want algae to be totally dry. That's a different type of binders available. Okay, as we can see here, different type of binders such as MMA and so on. Okay, and they have different properties and performance depending on the strength and also the setting time. The property of polymer concrete, as we can imagine, is largely depending on the amount and also the property of the individual type of polymer we use in the concrete. Okay. For example, polymer concrete made with MMA is brittle. Okay, as you can see from figures in this slides. Okay, and here shows stress and strain curve for polymer concrete. This is MMA only, or MMA with 5% of butyl alkylate or 20% of butyl alkylate. Okay, as we can see, for these three type of polymer concrete A, B, and C, the final strengths and also the modulus of elasticity are very different, as well as the post-peak behavior. For MMA only, the material is very brittle. Okay, so after the peak load, that's almost sudden failure for these materials. But for C, after the peak load, the concrete can still resist a certain type of load. So the toughness of this concrete is much higher compared to A, okay, MM only. So modify the composition and percentage of different polymer, we can change the performance of polymer concrete quite a lot. The figure on the right shows plain concrete versus polymer impregnated concrete. All right, and we can see polymer impregnated concrete has much higher strength. Okay, and also the E value, which is can be seen from the slope of the stress and strain curve, is much higher for polymer impregnated concrete. So higher E value and also higher strength, but it is more brittle. Okay, so not too much deviation from the straight line for polymer impregnated concrete, but for traditional concrete, the E value change over the different strain and then feel less brittle compared to PIC. Okay. So the property of polymer concrete, it has definitely higher strength and also has good chemical resistance and also higher initial strength, as well as higher modulus of elasticity. So we use this type of materials for emergency repair and overlays. Okay, We use for overlays because the cost of this material is much higher. So just a thin layer on top of the materials to enhance the strength and prevent the penetration of the harmful materials into the concrete. The thermal and the creep property of these materials are not as good as traditional Portland cement concrete. Okay, it is susceptible to high temperature, changes performance, and also the creep is much higher. Okay, and because of that, we need to reduce the loading stress level to less than 50% of the ultimate strength. For sustained loading at stress level of 25%, did not reduce the ultimate stress for a loading limit of 1,000 hours. So we need to reduce the requirement, consider the higher creep for this type of materials. Okay. So it has larger long-term deformation, but it may relax, which means it could be a good thing because relaxation may cause stress redistribution, okay, of the reinforced concrete. The materials and production technology we use in latex modified concrete are the same as we use in normal Portland cement concrete. The only difference is we add a lot of latex, okay, which is colloidal suspension. We use latex as a chemical admixtures. Just consider latex as a chemical admixtures. Again, there's a various type of latex with different properties. Okay, we can choose which type to use depending on the requirement of the applications and also consideration of other things such as cost. Latex generally has about 50% by weight of spherical and small polymer particles. And also the other 50% is water together with surface active agent. Okay. And the surface active agent in the latex may cause a lot of entrained air, so generate a lot of tiny air bubbles in the concrete. So if we do not want that, we may use air detraining agent. So just another chemical admixtures to reduce the air, get rid of the air in the concrete. Okay, it's called detraining agent. Generally speaking, about 10 to 20% of polymer by solid, by weight of cement is used in typical latex modified concrete equations. Again, we use latex modified concrete only in overlays where we need high durability or when the environmental condition is not good. Okay. And also we should add as little actual mixing water as possible for latex modified concrete. Okay, to ensure a good durability by reduce the permeability. Okay, just enough water to make sure the workability is okay. And here shows traditional mixed proportion for latex modified concrete. The water cement ratio is around 0.4 to 4.5, and the cement content on the higher end, around 650 to 700 pounds per cubic yard of concrete. The hardening process of latex is by drying or loss of the water. Okay, and dry curing is mandatory. So this is another difference between latex modified concrete and traditional concrete. For normal concrete, we want a wet curing, but for latex modified concrete, we want a dry curing because the concrete is hardened by loss of water. Okay. Okay. And these materials will form a polymer film which coat the cement hydration product, coat the aggregate particles, or even seal the pores, the capillary pores inside the concrete. Properties of latex modified concrete. The tensile strength will greatly improve because polymer can stop or reduce the crack propagation under tensile stress, but only moderate improvement on compressive stress. Okay, so we should remember the difference of latex modified concrete on tensile stress and compressive stress. So they are different. Another good property of latex modified concrete is it can bond strongly with the existing structures and also resist the entry of water and some other aggressive ions and solutions. Okay. The reason for that, again, is because the polymer film can line the pores and also the micro cracks, so which can reduce the penetration of fluid inside the concrete. Okay. So because of that, latex modified concrete is very polymer materials for rehabilitation and repair job. The third and last polymer concrete is called, polymer impregnated concrete. The reason for polymer impregnated concrete is, remember, the voids are the reason for low strength and also low durability of concrete. Okay, if we can seal the voids and micro crack in the concrete with polymer, we can enhance both the strength and also the durability of concrete. So that's the idea why we need to use polymer to seal voids in the concrete. However, it is very difficult for a polymer to penetrate inside the little pores and the micro crack in concrete directly. Okay, so and because of that, we should select a liquid with very low viscosity, so it can penetrate deeper. Okay, but also we need to make sure before we penetrate the liquid in the concrete need to be dry and free of all the moisture. Okay, so the pores and the micro crack need to be dried out before we apply the polymer. The materials we use in polymer impregnated concrete is not too much different from polymer concrete and other latex modified concrete. As we can see here, MMA is used for polymer concrete also. Okay. And it is used in PIC here. This material has low viscosity, so it can penetrate relatively deep inside the concrete, and also higher boiling point, which means it will lose less due to volatilization. And also the cost of these materials is relatively low. So this materials, monomer, is first used to penetrate the concrete because monomer has low viscosity. We cannot use polymer directly because in that case, polymer cannot penetrate deep inside the pores. Okay, because we use polymer, after polymer is penetrated, impregnated, we need to add another step, which is polymerization. Okay, to do that, we have three options. we can use a catalyst, okay, or we can use radiation such as gamma radiation to polymerize the monomer. Okay. Or we use the third method, which is a monomer catalyst mixture penetrate the concrete, and then we heat the concrete to make it polymer. And here shows the sequence of operation. First, we just cast the concrete as what we did for traditional concrete. Okay, and because the quality of a concrete here is not very important, because if the porosity is high, if the concrete crack a little bit, all these pores and cracks will be sealed off by polymer later. Okay, so no special care is needed in this step. We do have requirement for the thickness of the section, because if the thickness is too high, the monomer cannot penetrate deep enough. So we should have a maximum thickness of section about 150 millimeter, which is around 6 inch only. Next step is to cure the element. Okay, so we need to cure at room temperature, moisture curing for 28 days, sometimes even 7 days is enough. Okay, because again, the ultimate property of PIC is not really depending on the concrete quality. And sometimes we use thermal curing to enhance the turnover rate. So after the concrete achieves its strength, then we need to dry the moisture. Okay, we need to remove all the free water in the concrete from pores. Okay, we can use drying temperature just a little bit around boiling temperature of water for 3 to 7 days. Or we use higher temperature within 1 or 2 days. After dry the concrete, then we need to soak in the dried concrete in a monomer. So the monomer will penetrate inside the concrete. Okay, we can use surface pounding method. Okay. And then we need to seal the monomer. That is to prevent the loss of monomer by evaporation during the handling of the polymerization process. Okay, we need to seal that. We can just seal in containers, or we use aluminum foil to wrap up the members. We can even cover the surface of the members with sand, okay, as you can see from here. And then the last step is to polymerizing the monomer. Okay, as we said, we have 3 ways, and the thermal catalytical polymerization is preferred techniques, because the polymer is already mixed with catalyst, so we only need to increase the temperature to transfer the monomer into a polymer. Okay, so within several hours, the monomer will become a polymer. The monomer will become polymer. Right. So compared to normal concrete, PIC has greatly improved the tensile strength and compressive strength. Okay, this is different from what we just discussed about latex modified concrete. For latex modified concrete, the tensile strength increase, but the compressive strength does not increase as much. So this is for latex modified concrete. But for polymer impregnated concrete, both the tensile strength and the compressive strength will greatly increase, as well as durability. All right. So in summary, we discussed three types of polymer concrete. They are polymer concrete, which has used polymer as only binding agent. And then we discuss latex modified concrete, which latex is basically a chemical admixtures in normal concrete. And then we discuss polymer impregnated concrete, which is a treatment of traditional concrete after the concrete hardens. We use monomer to penetrate the concrete and then polymerization, the monomer, to seal the crack and the pores. Okay, so they are fast setting, can achieve the strength within several hours or even several minutes. The strength generally will be much higher compared to normal concrete, but depending on whether we talk about tensile strength or compressive strength, different polymer concrete has different performance, and also low permeability. For all the three types of polymer concrete, permeability will be much lower, so that will translate into better durability. However, remember polymer concrete is sensitive to temperature, UV light, and also creep will be much higher compared to normal concrete. Finally, remember polymer concrete is very expensive, so we only use that in situations such as overlays, emergency repair. So yeah, keep that in mind. Okay. That is the end for lecture number 18.